thank you very much, Anita and Olivia, for inviting me here. It's very nice to be here. Thank you also, Natalie, for your talk. It was very, very good because you give an introduction on NLP. And I will present to you a practical approach to that. Need to, no? Okay. So, good morning, everybody. Today I will present this project titled Machine Learning-Based Early Warning System with Social Media Data. Not so many years ago, if a person had a complaint about a service or a product, it just took the phone and called the company. Nowadays, it's completely different. All the complaints come through social media. And this is a big change in customer behavior. And companies spend a lot of resources in attending these channels. But we have to be aware of is that these kind of complaints, social media complaints, are massive and even messy traced conversations that everybody can listen to and participate. And still, companies are handling them as they were a one-to-one phone call, a private phone call, through manual, slow tasks. And this represents a risk not only for the efficiency of the work they have to do, but also to reputation, customer satisfaction, and what I'm going to show you today is how machine learning can help approach this problem more efficiently. I did this work while working in faculty, an AI consultancy company based in London, and the work was commissioned by Yorkshire Water. I have to, sorry. I didn't practice my, okay. Yeah, this is the back.
This is the point.
The point, okay.
This is
right, okay, yeah. Well, this work was commissioned by Yorkshire Water, a water utility company that covers the northeast of England. I should, all right. Every day, a lot of messages arrive to Yorkshire Water channels, Twitter and Facebook, among which some of them are relevant since they are messages related to incidents. Customers write these messages about no water, low water pressure, pipe bursts, traffic interruptions due to work. And the company has to attend these messages, and reactivity is crucial since we are speaking about a primary service like water. Still, the company, before having this tool, was handling this process manually. While keeping these channels responsive and active, the social media operators had to detect these messages, communicate eventually to the incident response team, who will later delineate a working plan. Later on, this incident response team had to update the social media operators in order to, about the working plans in order to update the customers. As you can imagine, due to the nature of the messages, as we were speaking before, the system can fail at different levels. So any missing message or delay in the response from the social media operators, or lack of working plans update from the incident response plan team, could end up in the escalation of the problem. This is where machine learning comes into action. So by applying different techniques, I built a tool that what it does is to detect incident and location information from the tweets, expose that information to both teams that will later on will plan the works to do and also interact with the customers. So here you see an overview of the flow of the pipeline that we will go later. First, I wanted to summarize some aspects of this project. It took 4 weeks to get a proof of concept and to build a minimal viable version of the tool. The programming language was Python, and the main packages regex, spaCy, and GeoPy. To have this tool done, I took historical data from one of the main channels, the Yorkshire Help channel, in which mostly people write about incidents. So we will go through the pipeline. The first step is the data preprocessing. Tweets are very informal writing text. They are subjected to typos, they have lots of abbreviations, and they contain lots of special characters, emojis, URLs, mentions to pictures or web pages. Since we are dealing with the extraction of text information, any NLP, natural language processing process is very difficult if this step is not computed. So I set a series of functions to ensure a text cleaning for the later processing. The core of the pipeline was location extraction. This is the main information the company needed to take actions and apply a combined approach. So classical regular expression tool that find the terms linked to, we are here, linked to the expression, streets, and all the variants, and also to find postcodes and all the variants, including the typos. Still, to have a comprehensive information about location, machine learning algorithm was the final approach. And since we are dealing with information contained in a text, this open source library, spaCy, was the appropriate choice. Among its capabilities, it has a name entity recognizer, a neural network that was trained to recognize and classify real-world objects. What I mean by this, persons, buildings, locations. It is a library that contains this neural network trained for different languages, and we focus on also trained with different types of text, any kind of text, a massive amount of text documents. We focus on English language NER, and since we wanted to get location information, we focus on the tag tokens related to location. What it is, the goodness of this is that it not only recognizes what we could think of as a classical location, which is a city, and a street or a postcode, but also buildings, airports, highways, or natural locations like mountains or bodies of water. As I said before, customers complain the kind of writing text in the tweets can contain any information related to the incident. And so this was a plus for us. Here you see a really simple example where regex comes into action by recognizing main or road, because it's linked to the word, the expression of a street, road, and the NER recognizes green in Orsett, which is another street name, and the city. It is to get the location into a functional use from the operators. They have to be placed on a map. And they have to be converted into geographic coordinates, longitude and latitude. And here comes another tool that was very useful. It's the OpenStreetMap. Is one of the main open source for geographical data. It provides both the addresses and the geographical coordinates. And to convert from one to the other, in our case, from address to longitude and latitude, it provides an open geocoding web service, which is called Nominatim. All this was embedded into a GeoPy package in order to get the output. And here we have an example. Here we have an example of all the tweets that contain location information that were placed as a dot on a map. Just a keynote, the tool is very effective, and 88.5% of the locations were successfully geocoded. By the end of the speak, I will learn. Good. Okay, since I apply a multiple approach, regex and an error, the location information has to be subjected to a metric of confidence. This is the last step, and this is an analytical step. This metric of confidence was based on what? On an analysis on how consistent is location information from the different sources, if there is more than one in each tweet. And an analysis on the behavior of coordinates when all three sources are present together. So, shortly, which info are more often clustered together. Based on this previous analysis, I established a leveling criteria, low, middle, high confidence. Why? Because what I wanted to do is to guide the operators into seeking more information about location in the cases where that information was incomplete or had low confidence. This pipeline was embedded into a dashboard. This dashboard basically is the tool where these operators with what interact. And how it works. So the live tweeters coming from the different channels are streamed and ingested into this mail pipeline. If they have location information, they appear on the screen. And if that location information is successfully geocoded, it appears on the map. It comes with a series of functionalities based also on the analysis, like being verified or unverified, being solved or unsolved, in order to make the work easier for the operators. In here, what I show you is the final, this is just the final shape of the dashboard. I brought an example. This is a recent flood in an area. Perfect. This is a recent flood in an area of the north of England. And thanks to this tool, they were able to manage the situation successfully. We were speaking about, at the very beginning of the talk, about reputation. Okay, the press perceive the action of all of the company in a positive way. So, to conclude, this is a scalable tool. Indeed, many other functionalities were added to it later on. Now the company counts with an early warning system, right? All these tweeters are spontaneous texts that people write at the moment they are leaving the situation, like a road interruption due to work. So they have a better incident response planning thanks to this. Also, they count with an effective tool to deal with a social media complaint, so they get to have a better customer experience. Thank you.
Thank you very much. Yeah, it's great to see what we can do with our social media data in a positive way. I think for most of you, it's known that there's so much information in what we do on social media, and it's also nice to see that the companies, they start to use this really to have a better interaction with their customers, because yes, as you said before, we don't call anymore the people, we just post on social media. Okay, open for questions to Natalia. I go there. I have to keep them in touch. Okay.
Yeah, thank you. My name is Eva from Fraunhofer, and I have a question. Do you have a good strategy how to deal with irony in customer complaints?
How to deal with?
Ironical statements. So instead, you want to report on a disaster, but you start, oh, what a great day. I had no water, I had a leak. So ironical phrases in text.
Oh, okay. Well, this was not a project here yet, but as I said before, it's open to a lot of functionalities. One of those that I didn't speak about is about a topic, because here we are not classifying the text by topics. No water pressure, or no water at all, or even the intention of the text, as you were asking me before. So we are not dealing with that, but of course this is another block that could be added to the tool. Is it that what? Okay.
Another question? No online questions? Okay, so in the room, Christoph, just in front of you.
Oh, thank you.
Yeah, thank you very much for your talk. I thought maybe you considered that opportunity, or you would maybe think about it, but some messages are not, let's say, reporting on the current situations, but they report on something like, I have no water 1 week ago, like, how dare you doing this, and such things. Like, would you maybe be interested to also analyze the temporal information from the text languages as well?
That would be great. Still, as you saw, the tool allows you to first detect what it is, a message that contains relevant information, and then the operators can dig more into the situation. So even if it's not complete, as you might think of, like detecting a past message, not something, an incident that happened in the past that might not be today, might be fixed today. So the tool is still able to handle that situation and to organize in a logical way all the messages that are arriving. So we didn't think of, but of course is again another block that can be put into the pipeline.
Okay, thanks. I have to look a bit at the time. If you have further questions to Natalia, we have a lot of breaks. You will be here the whole day.
Absolutely. So if you have any issue you want to talk about, yeah, I'm welcome.
And online also, if there are online questions, if we cannot answer all online questions, we will just summarize them, and then we will send them to the speakers and ask you to maybe respond to them afterwards. Thanks a lot.
Thank you.